Alright, this is just a quick video for those of you who are absent on the 26th. We're just going to be doing a lab Wednesday that goes over all this, so I just want to make sure you know the terminology. But on a piece of paper, if you could title this, title the top of it matter, because we're going to add to it. This isn't the only notes we're going to have on this piece of paper. Okay? But I just want you to know the difference between a physical change and a chemical change. So a physical change is something where the substance stays whatever substance it is. It may change shape, it may change whether it's a liquid or a gas, but it's still whatever it was. Okay, so examples like melting ice. Ice is water molecules, whether it's a solid, whether it's melted and it's a liquid, or if you've boiled it off into a gas. All right, or you take a piece of paper, you tear it in half, you still have two pieces that are paper. Technically, you could put them back together, okay? If you reshape something malleable, like a copper wire, if you twist it around something, or even take a piece of paper and fold it, all right? That's a physical change because it's still the copper wire, or it's still the piece of paper. Last one, mixing salt and water, or salt, or say water and sugar or something like that. That's also a physical change because you're just dissolving the salt. If you let the water evaporate, you get the salt back. All right, so it didn't permanently become something else. Whereas on the other side, chemical changes, which you can also think of as being a chemical reaction, actually completely change what you're working with and create something new. If you burn paper, it becomes this black pile of ash. You can't get paper back from it. It's now you've given off the oxygen that was in the paper and made CO2, or the carbon combined with oxygen to make that. The paper itself is no longer the same molecules that made the paper. It's been split up or combined in other things. Digesting your food. If you eat a hamburger, it doesn't sit there and stay a hamburger in your body. Your body breaks it down, uses it to make ATP to move your muscles, uses it to, put blood sugar, everything. Okay? Or, like the picture on here, iron reacting with oxygen gas. Some metals are made out of iron, and if they're exposed to oxygen and water, they'll rust. All right, that rust, it's permanent. It doesn't go back. If you clean rust off, what you're doing is you're actually just taking a layer off of the metal and then making it thinner and getting it back to the part that hasn't been exposed to the oxygen and the water. Okay, but if something rusts completely through, there's nothing you can do about it. Okay? But just keep in mind we are going to have a lab, so make sure we have closed-toed shoes and hair ties, because it's going to involve fire and it's going to involve acid, so it's definitely want to make sure we are doing everything we can to safely have fun with those things. See you in class.